guys, so this is Joel. Welcome back. We'll continue with our discussion on AWS here. Till now, you would have seen me doing a bunch of videos on IAM, EC2, EBS, and ELB services, and which were probably, which still needed for a good, healthy AWS discussion. But today we'll actually venture more into something which is close to networking. In fact, very, very close to networking, which is the VPC, right? The Virtual Private Cloud. During this discussion, I think you'll see a lot of connections and a lot of similarities to our traditional networks, right? So that being said, let's get to it. So what is VPC? To start with, before you even talk about VPC, we actually need to talk about your classless, IP addresses, classful IP addresses, on the public addresses, private addresses. But obviously, I'm going to skip that part because we are all network engineers, and I'm pretty sure we all know about that. So VPC is basically a virtual private cloud, right? Think of it as, in simple terms, think of it as how Amazon kind of like houses your instance and then connects it to the rest of the world, right? So there should be some piece of network, right? There should be a router, there should be a small routing protocol probably, and there should be a routing table, and there should be an internet gateway, there should be a NAT if needed. So a simple network, right, which basically allows our instance, right, which we spin up every time, right, EC2 instance, to kind of connect to probably other EC2 instances, at the same time connect to the rest of the world, right? And not just connect to other instances, probably connect to other AWS services, right? Even that also comes under this kind of a discussion, right? So that being said, let's actually go through what happens. So let's go to the VPC service as such. Right, and here you can see by default, right, VPC is actually created for you, when you have logged in, right? I don't even have an instance right now, but there is already a VPC, created for me in my Mumbai region, right? Because that's what I have selected. And you can see the VPC. If you go down to the information about that, there you go. This is the default VPC, and there is a subnet also which is assigned to you, which is /16, right? 172.31, and it's /16, right? You can see here. Apart from that, you can also see on the left hand side there are a bunch of other things like the subnets. You can see there are /20 subnets in all the three regions. In fact, all the three availability zones, right? 1A, 1B, 1C, right, of my Mumbai data centers, right? So these are the three availability zones, and I have been given subnets. Again, I've not done anything here. This is by default. You create an account, you go down to your VPC, you should be able to see that as well. Then we also have on the left hand side, okay, actually let me go back to the older experience. I like that. So subnets are good. Then let's see the routing table. So routing table, there is a routing table here, right? Like I said, because it's a small network in itself, it should have a routing table, right? So to tell the instance how to reach out to the world and talk to other instances and such. So here you can see under the routes, you can see there is a route for the local route, because this is the /16 route which is allocated for our VPC, and that is tagged with local, whereas for all the default routes, you see there is a gateway, right? So this is the gateway, and if you want to see more about the gateway, you can go down here and you can see this is the gateway attached, right? So these are all various nuances, when we talk about the VPC of AWS, right? So now apart from that, is there anything else? So, and then probably there is also what we call as the ACLs, right? Very traditional ACLs, like how we would configure ACLs on our routers, right? For layer 3 filtering, right? Or probably on firewalls, right? Very similar to that. We have network ACLs in AWS as well, which is going to have a bunch of inbound rules and outbound rules. By default, you can see all traffic is allowed outside and all traffic is allowed inside, right, in the network ACL. But we can obviously play around with this and change it, right? Just remember the network ACLs are more like stateless, whereas the security groups, which we have talked before, are more like stateful, right? That being said, there are a lot of other cool stuff. Probably if we get some time, we'll definitely check this out. But to start with, let's play around this. So first thing what we'll do today is, so this is the default VPC, right? I kept on saying this is the default one. We did not create it, right? So what we are going to do is we are going to create our own VPC in this video, right? So think of it this way. We are actually stripping down the whole AWS and we are building it completely just like we want, right? So we are going to create an instance, we are going to create a VPC, we are going to put that instance in that VPC, we are going to give internet connectivity to that instance, and we are going to make that instance talk to other instances and so on. So we're going to do some fun stuff. Alright, so first thing, so because I had promised myself not to touch the whiteboard, but for this discussion I think it is necessary, otherwise it would become very weird without the actual this thing. So what I'm going to do is I'm going to at least put in a quick diagram or whenever I'm adding stuff to my network, right? So let's do this. So we would probably need, let's start with what we say the first outside stuff. So let's just get a different one. Okay, don't mind my terrible drawing skills, but anyway, so what we'll do is on the outside, right, let's say we have our first let's call the whole thing as nothing but your AWS over here, right? And we are going to put in our, let's put our VPC, let's create our VPC. This is the whole AWS network, right? Think of it that way. And our VPC is just a small virtual private cloud inside the whole AWS. So you can think of this as the whole, AWS data center maybe, right? Maybe the whole data center, and this is where we are going to create our small VPC, right? So it's inside this. So I wanted to call that out, right? So let's do this, right? So we are going to call this guy as the VPC. Okay, just give me a second. All right, so this is what we have. We have not done anything as of now. We have the AWS network. We have our we have the slate clean, right? This is what we intend to do: build our VPC inside the AWS network. So let's start with creating our own VPC. I'll put the VPC here, so let's go and create that first, right? So how do you create your VPC? We have an option here called create VPC. Let's go and do that, and inside that we can give a name, right? So I'm gonna give it as demo VPC, probably makes sense. Now here you can define your CIDR block, right? It's a classless CIDR, right? Basically you need to provide your subnet, right? Basically the complete pool of network which you'll be using inside your VPC, right? So let's get to it. Let's put in 10.0.0/16, right? So let's use this as our CIDR block. You can even have IPv6, but I really don't want it now, so I'm going to create it. So there you go, our VPC is created. You can see here, this is the one which we just now created, which is good. I'll obviously not spend time in talking about the CIDR block because this is pretty straightforward, right? We have how many /16 is basically 2^16 addresses, can be created in this particular block, the whole block, 2^16, right? Cool. So now, if you want to add more than one CIDR block in a VPC, you can do that as well. So you just need to do edit CIDR here, and you can add more as well, right? Now I have /16. Probably you want to add one more subnet to this. Go ahead and add it, right? Basically, it depends on how many networks you want, depending on your design, right? In my case, one big whole /16 subnet or one big whole /16 network is more than enough for me. Cool. So then the next is, so what we have done here right now is we have created our VPC. Next is we have to create two different subnets, right? So let me draw that as well. So we are going to go and create two interesting subnets here, and we are going to call that as the private subnet and the public subnet. So let's go and put that. Yeah, okay, that's fine. So this is going to be the this will be our, what is this? This is going to be our public subnet, and this is going to be our private subnet, right? So we're going to go and create two different subnets, right? You will understand once we build the whole picture why are we doing this. So for now, just like you saw me doing the creating the demo VPC, we are gonna go and create the private and the public subnet, right? The public subnet is basically the one which will have internet connectivity, and the private will be the one which will not, right? So that's how you distinguish. Anyway, so let's go and create the subnets. So I showed you the subnets which are created by default here for the default VPC. But if you select my, this is the, okay, so I still don't have it. Let's refresh it here. Yeah, so now I can see the two VPCs, right? This is the one which I had created. And if I select that, I really don't have any subnets associated with my VPC, right? The subnets which you see are actually the ones which are associated with the default VPC, which gets created by default, right? So that being said, let's go and create the two subnets which I talked about. So let's say create subnet. So here I can put a tag, right? So let's put the tag public, public subnet, let's say A. So what I'm going to do is I'm going to create two public subnets in two different ACs. You know, think of it mainly for redundancy purpose, right? You can do that. You can create your subnets in different ACs as well. That way you have redundancy, right? So let's do that. So let's create this, and in the VPC, obviously I have to select my demo VPC, right? Because I want to create this subnet inside the VPC which I am creating, and I'll have to provide the CIDR block. Now here, I'm obviously, because this is a public subnet, I really don't want a bigger pool, so I'm gonna reduce this /16 to 24, and that should be it. So I'm taking a small chunk of the big CIDR block for my public subnet A, right, which is /24. I'm gonna say create. Okay, and I'm not sure in which AZ did it create. I should have selected that. Let's check that. Oh, okay, it got created in 1B. So let's see if I can edit it. Probably, can I? I don't think so. Let's see. Can I edit it? Okay, maybe not. So what I'll do is I'll just delete this guy once, because I want to create him in the AP South 1A, right? So let's do it again. So let's put this. The VPC is obviously demo. See, this one I should have selected AP South 1A, because this is public subnet A. I want to create it in the 1A availability zone, and this guy is gonna be 10. Like I said, it's gonna be 10.0.0, but /24, right? I'm just using a small chunk of it. So there you go. That's good. Now what I'll do is let me go and create. I think there's a small bug here. Okay, cool. This is good. So let's go and create the second, guys, the second public subnet, right? So this is going to be in the AZ1B, right? Let's select the demo VPC. Availability zone is 1B, and the CIDR is 10.0.0. Sorry, it's not 10.0.0. We have already used that, so I'm going to use, say, 10.0.1.0, right? /24, because I can toggle these two octets, right? Because I have /16 as the CIDR, right? So I'm going to use that, and this is 1B, and this is looking good, so we'll go and create it. All right, looks good. So we have done both our public subnets. Time to create our private subnets, right? Similar fashion. So I'm going to say, let's just get rid of this. I'm going to say private. So this is going to be private subnet A. The VPC has to be selected. Preference is 1A. The network, but now because private subnet is the subnet where our instances is going to live, right, most of the time. So we would obviously want, because public subnet is the place generally where your load balancer live, right? Whereas private subnet is the place where all your instances, your web servers and all of them, web servers and all of them are going to live in the private subnet. So I'll have to give a bigger pool here. So I'm going to use 10.0 dot probably 16.0, but I'm going to go with /20 here and not 24, right? I want to give a bigger pool here. Cool. So that being said, I mean, I can use anything. I can use 2.0, 3.0. I just went with 16.0, but I can use anything, right? But be careful. Give a bigger pool because it's a private subnet. Anyway, so let's do that. And the last guy I want to create is, obviously, you guessed it right, in the AZ, which is B. Let's see. So let's select Let's go to B, and here I believe the previous subnet ends at because it's /22, it ends at 31, so I can use 32.0/20, right? I think that should be it. Makes sense? Yep, there you go. Cool. So let's just quickly verify, right? I can filter it out for the demo VPC, and you can see these are the 4 subnets which we just now created. We have public A, public B, private A, private B. Okay, makes sense. You can see the availability zones, the subnets, everything looks good. I am happy with that. Okay, just a note here, you can see here, you might be wondering, when it is /24, generally there should be 256 addresses, right? Shouldn't it be? Because /24 means you have 8 bits, right, to play around, the last octet in fact. So 2 power 8 is 256, but you can't like use all 256 addresses because 5 addresses are kind of reserved, right? That you can't use them because AWS reserves it for some internal purposes. Like one of them is the network address, one of them is reserved for the VPC router itself, right? Then I think there is one more used for mapping the mainly for DNS purpose, right? And stuff like that. So basically 5 of the addresses are not usable. That's why you see 256 minus 5, 251. Similarly here as well, 4091, right? Just a note. Awesome. So next, what we'll do next is, so we have created our subnets here, which is good. Let's go ahead and create our instances, right? Our instances, our EC2 instances. So for that, let me open a new tab. So let's go to EC2. I mean, there's no point in creating just the VPC without the instances, right? So that's why you have to launch an instance. Traditional instance, our Linux 2, T2 micro configured, and here now you have an option, right? I can select demo VPC, right? Because this is the VPC where I want to create my instance in. So I'm going to create that, right? So give it a second. Yeah. Do I have a diagram for this? Let me see. I'll draw that later once we create it. Okay. So so we're going to create it in the demo VPC, and now you have the option here to select in which subnet do you want to create this in. So to start with, I want to create this guy in my public subnet A, right? Think of, I mean, normally I would put a load balancer, but for our example here, I'm just putting an instance itself. So there you go. So I have public subnet A, and there's an interesting thing here. Use subnet settings. So auto assign public IP, and it is currently set to disable. The reason is because we have to do something here. So we have to go to, let's say, go to public subnet A, right click here, and you have an option called modify auto assign IP settings, right? So when the instance comes up, if you want that instance to automatically get a public IP address, right, then you have to change the settings over here. So here you see there is an option called enable auto assign IP address. So you need to enable this guy, right? So we got to do that for both the public subnets. So let's do that. Modify, save it. There you go. Now if I refresh this guy here, okay, it takes me back here. That's okay. And let's select demo, and let's select public subnet A, and there you go. Look at it has changed from disabled to enabled here, right? So now the instance will get a public IP when it comes up. All right, so I'm happy with that, which means we are good to go to the next step. Add storage, traditional, not going to do anything. I can add a tag. I'm going to add the tag of, I'm going to say public instance probably, right? Just for yeah, so I think that looks good. So it's going to be a public instance, which is fine. Then we'll say add a security group, right? So in the security group, I would just want SSH into it for now. So probably I can just retain this guy. Probably I'll give a name for the security group though. So I'm going to say public-security group. Okay. Probably the same thing in the description as well. Right, that looks good. Review and launch. I can use the existing EC2 bits please, so that's good. So while that comes up, it'll probably take a few seconds to come up. Let me pause the video and get my key. All right, so looks like the machine has come up, and you can see a public IP has been assigned to it. On the left hand side, you can see there is a private IP also assigned from the pool, from the public subnet pool which we had created, right? You can see 10.0.0/21/24 was the subnet, and you can see .71 has been assigned to our guy, right? And this is the VPC, the demo VPC. So an IP has been assigned from this pool which we created. Anyway, so this is the guy which we want to connect to the instance, right, from outside. So let's copy this and let's see if we can connect. So to connect, I would need my terminal. So let's pull the terminal down here. All right, so let's get this guy up here, right? So that's good. So what I'm going to do is, let's just quickly go down to the downloads folder, because that's where my key is. So I'll do SSHI and EC2 and what's the user, EC2-user. Sorry, let's get rid of that, and let's put the IP address. There you go. I'm not able to connect to it. Why? Because right now this particular instance doesn't have internet access, right? So I'm gonna cancel this out. Let's go back here. Currently this instance doesn't have internet access, right? It has been assigned an IP, public IP, right? But the instance itself doesn't have internet access. So we have to fix that, right? So let's come down to the diagram here. So we have done the public subnet, private subnet. So first thing is, next is we need to go and add what we call as the internet gateway over here, right? So the internet gateway, so let's just call this as the internet gateway. So we have to add the internet gateway, right, to our VPC to provide, internet connectivity, right, outside. So let's do that. How do we do that? So again, go back to the VPC management console and go to internet gateways here. You see there is no internet gateway right now. I mean, there probably is a default one which came with our default VPC, but for our demo VPC there is nothing. Anyway, so let's go and create one, right? I'm going to call this as I don't know, maybe demo internet gateway. Makes sense. So I'm going to say create, close. Right now it will be in the detached state, but that's okay. We have to right click on it and we can say attach to VPC, and here you can select the demo VPC, right? So once you say attach, right, so it gets attached, which is pretty cool, right? Now let's see if our SSH works. There you go. Still not working. What did we miss? Okay, so we have missed. So what we have done is we have attached the internet gateway. Let's go back to the diagram. We have created the subnets, right? Private subnets, public subnets, and we have put our instance here right now, right? So we have put our instance here. So let me draw our instance, right? So let's go here and we'll say, so this is our instance right now, right? I'm going to say public instance, right? I'm going to say PU instance. So this is our public instance, and we have also obviously put a security group. So let's put that also. Security group is always, think of it as it is someone protecting the instance, right, from all the directions, right, both here inbound and outbound. So the green one basically represents the security group. So I'm gonna just write it as security group here. Okay, so we have put the security group, and but this is it, right? And we also have so this is what we have done. So that's why are we not able to connect to the internet, because there is no connectivity. We have created an internet instance, we have created a EC2 instance, but there is really, they both are not talking. And if you want them to talk, what should you do? You're right, from a networking background, you need to put a router and you need to connect them, right? So we really need to have what we call as a routing table over here, right? So we need a router obviously and a routing table to be created, right? And once we have that routing table, we can peacefully go and we can connect it in this way. So basically, let me use a different color maybe here. We have more colors, probably not. Okay, use a different color just for the routing part. Let's probably use blue. Okay, so we would need okay, that was bad. Let's go and use something less. Okay, so we basically need routing. So we once we put the routing table, right, let me go back to my old this looks really bad. Okay, so we would obviously need a connectivity, right, from the instance, right, and we would need to point it, right, in this direction, and the routing table will basically route the traffic out to the internet gateway. So you need to put in a router over there, and you need on the routing table we'll have to put a default gateway or default route, static route, kind of like a static route, saying all the traffic, right, which is destined to the internet has to be sent to the internet gateway, and then the internet gateway will basically take the traffic and send it outside, the actual internet here, right? Right now there is no connectivity, or there is no there is all these pieces are working in silos, so we need to put them all together using the routing table. So think of a routing table as the guy who basically puts all of these together, right? So that being said, let's go back to our VPC, right? So where is the routing table? This is a routing table, right? Again, this basically gets created when you have, so this one gets created for our default VPC, and this gets and this one gets created got created for our demo VPC. So one routing table per VPC gets created by default, but we want to create our own routing tables and use them, right? So that you can see these are the main routing tables. They are still going to be there, and they're going to have the routes, basically the whole CIDR block, right, assigned to it, and that is going to be present, right? So like I said, I don't want to use you can obviously go and edit the routes in your main routing table and add the subnets here, but to keep it clean, it's always better to create your separate routing tables for every of your subnet, right? So I'm not going to touch these default tables which come. I'm going to create, there you go, create a routing table, and we'll have to create a routing table for our public subnet and private subnet, right? So let's go and do that. So this is going to be our public routing table. There you go. This is a private public routing table, and we'll have to select our demo VPC, right, because we're creating inside it. Let's go and say create, and we'll also simultaneously create one more guy, which is our private. Need to change this, and the VPC as well, and I think that's good. So let's say, there we go, create, right? So we've got our so let me just filter this out to the demo VPC, and you can see this guy is the default one, right, which gets created by default. So don't bother about this guy, just concentrate on the, let me just see if I can pull this a bit. Yeah, so there you go. So we've got the private, we've got the public. Okay, now what you gotta do, just creating a routing table is not enough, right? You need to, so let's select our public routing table. You need to attach the subnets associated to it. So where do we do that? So you can see subnet association here, and currently all the subnets by default, right, would be associated with our the main table. So we have to just attach it to the public routing table which we just now created. So we'll say edit subnet association, and which are our public subnets. So you can see here, this is public, this one is public. I'm gonna say save, right? By doing that, you can see the two public subnets have been attached here. Let's go and do the same thing for our private routing table, edit subnet, and which are our private. This is private, this one is private. Save, right? There you go. Pretty cool, right? So it was that simple. We created a routing table, we attached the subnets in the routing table. Now you can see those subnets associated here. Awesome. Next, now coming back to our discussion, right? What was missing? I was saying we created the routing table, which is good. We actually created the routing table here as well, right? We created a routing table for the private as well. So we have created the two routing tables. But now the most important part here is, right, the routing table knows about the public instance, right? Because it, let's see the public routing table. Where is it? Right. So this is the public routing table, and our instance is actually present in this particular subnet, right? So it already knows about this one, right? Because it knows that this particular route is part of the local VPC, right? So it knows about this particular subnet, but it really doesn't know what it should do with the routes which are destined to the with the packets which are destined to the internet. So we need to add a route, right? So we'll have to add a route, and this route is going to be default route, right? So the default route is going to be pointing towards where? The internet gateway, right? So let's select the internet gateway, and see there is an internet gateway which we created. Save, close, right? So by doing that, let's go back and check now what would have happened. Right, there you go, we have connectivity. Awesome, this is what we wanted, right? So right now we have done this. We have successfully created an instance, connected it to the internet gateway using the routing table, and we are able to connect the instance to the internet. I mean, you can check that. You can do a ping to, I don't know, google.com, right? There you go, you are able to do that. So it basically has internet connectivity. Awesome. Next. What we'll do next is we'll talk about NAT. So what we'll do before that is, let me just draw a diagram here. Right, so right now we have done this, but imagine next is we'll go and create an instance in the private subnet, right? So let's call this another instance. So here, and obviously it is also going to have a what? It is going to have a security group, just like this, instance. I'm just going to color all the instances probably just for the sake of, so these are both our instances right now. So this is good. So we are going to create a private instance. But the private instance, right, will be only able to talk to this routing table by default, right, which is okay. But what if I want my private instance to reach out to the internet, right? Then our traditional NAT comes into play, correct? So our traditional NAT, when I talk about traditional NAT, I would need what we call, so there are two ways of doing this, right? There are two ways of doing this. Well, the first way is using what we call as a NAT instance, and the second way is using NAT gateway, right? We'll look at the first option for right now. So what we have to do for that is we'll have to create what we call as a NAT instance here. So I'm going to say NAT instance, right? And obviously it's just like any other instance. So it's also going to have a security group of its own, right? And this is going to be as simple as we'll have to connect our routing table, right? Or we'll have to put a default route on this routing table towards this guy. Right, and this guy will then, right, will be able to connect to the routing table. Because this one will obviously get a public IP, so this routing table will obviously know about it, and this routing table already has a default gateway to the internet gateway, and the traffic would go out, right? So this is one way of doing it. There's another quicker and easier way which I'll show next, but this is what we are going to try first. So we'll create a private instance. Right, we'll create a NAT instance and we'll show you how we can reach out to the internet from the private instance. So that's going to be the next step. Cool. So let's come back here. Let's go to the instances. Let's say launch instance, and instead of selecting the Linux 2, what we'll do is I'll search for NAT here. There are a lot of AMIs, right, in the AWS marketplace, but let me go to the community marketplace and pick the first one here, right? So there you go. So let's say I'm going to use T2 Micro configure instance, right? And this guy, right, I have to put him in the public subnet, right? Because I would want a public IP address to be assigned to this guy. So this is the VPC. Now the public subnet, I can select A or B. In fact, I'll go for redundancy purpose and I'll select the public subnet B in this case. All right, so that being done, it is going to get a IP address. I'm happy with that. Let's go and add storage. That's good. Tags, probably a tag, right? It's going to be name. And here I'm going to say this is our NAT instance. Okay, there you go. So we'll say configure security group, and the security group here would be basically we'll create a new one probably, right? I'll call this as the NAT security group, so we have SSH. Let's also add HTTP and HTTPS, right? Because this guy, right, will have to allow HTTP and HTTPS, because if we host a web server, right, on our private instance in future, we'll have to allow the traffic, right? So that's why we'll go and we'll add the rules for HTTP as well. Not sure if we'll use this, but let's for future purposes, let's add this. And when we are adding here the source, what I'm going to do is I'm going to restrict it to only our VPC and not everyone else. So I'm going to do only /16 here. Same thing goes with HTTPS, and here as well it's going to be 10./16. Okay, so HTTP and HTTPS have been created. and this is good. So this is our NAT security group. Happy with that. So we'll do review and launch, and you can keep everything default. Next, launch. Right, so this is fine. There you go. Now while that guy is coming up, let's go and create our private instance as well. So our private instance is going to be our traditional one. Next, right, and here we'll have to select our demo VPC and the subnet. In which subnet do we want this guy? So we'll go to private subnet A. Okay, we don't want a IP address, public IP for this guy, so it's going to be disabled, obviously, and that looks good. So we'll add storage, and this is good. Add tags. We'll say name, and we'll add a private instance. Sorry. Okay, so that looks good. So we have a private instance. Security groups. What kind of a security group do we want? For now, let's just stick to our SSH, right? We'll see if we want something more in future, but for now this is good. And review, launch. While creating the key pair, let's actually create a new key pair this time. So let's say create a new key pair. I'm gonna call this. Just keep something very simpler name, private. Download the key pair, launch instance. Let's look at the instances. So we have created these two instances which we were talking here. We have created the private, we have created the NAT instance. Right? We can see those. Now this guy is coming up. So let's wait for it a few seconds. Meanwhile, what we'll do is there's one interesting setting which you need to change for what? For the NAT instance. Now the NAT instance, so actually any instance in EC2, right, there is one rule. I'll show you what that rule is. So here it is, right? So where is that? I believe you should find it. Should find it under networking, I guess. Yeah. So here you go. So we have a rule which says there's a check actually. There's a check which happens called as the source destination check, right? So any instance will not forward the traffic if it finds that the traffic was not originated from it or is not destined to it, right? But for a NAT instance, that kind of a rule has to be disabled, because in a NAT instance, the traffic is not going to be originated by that guy, right? The traffic is going to be originated generally by the private instance, and NAT is going to just NAT it out, right? So the traffic won't be originated here. So we'll have to disable that particular rule here. So once we are done with that, right? Let's see. What we're going to do is we'll go to this private instance and we are going to SSH into it, but we have already SSHed into it here, right? We already are inside here. So once we are here, let's actually from the private instance, this is what we are going to do. So this is the public instance. We are already here, but from here we have to reach out to the private instance, right? Because the private instance doesn't really have a public IP. So we have to, from this guy, we should see if we can talk to the private instance. So let's try that. So before that, we want that key which we just now created, right? So we'll have to copy this guy over here, and let's go to our window, our terminal, right? So let's create this guy. So we're going to say nano private, I believe, dot pem, right? So this is really, I'm on my public machine, right? The public instance. So I'm going to go there because I have to connect to my private instance from here public instance. I'm going to paste this guy here. So Control X. Okay, there you go. So I have my key here. So I'm going to do chmod, and we'll have to change the permissions of this guy, right? So let's do that. There you go. And once we are done with that, what is the next step, right? So what's the next step? So from here, let's see if we can connect to our, so we'll have to do SSH -i and this private guy. Let's select that. Sorry. Okay, actually let me clear the screen a bit. I think it's too much, so let's clear it. Okay, so there you go, and we'll have to put in the EC2 -user, and what's the IP address? So now we'll have to use the IP address of our private instance, which is here, this one, right? So let's copy this, and there you go. Awesome. I'm able to connect to it, right? So I'm actually, what I've done, I've kind of like logged into, or I've actually connected to my public instance first, and from there I did a SSH to my private instance and I'm able to connect to it. But if you see now, do I have internet connectivity on my private instance? Nope, I don't have internet connectivity. So let's try to fix that, right? So to fix that, we will have to go down to, so like I said, very similar to what we did, right? We have to put that route, we have to put the route in the routing table over here, which is pointing towards the NAT instance. So right now that is missing. So we'll have to go down to my VPC routing tables, right? Let's go to the private routing table over here. So in the private routing table, let's edit the routes. Let's add a route, which is the default route. But this time I'm going to select the NAT gateway, which I just now created. Interesting. Sorry, not the NAT gateway, the NAT instance, right? NAT gateway is the next lecture. So we'll select the instance, and here we'll select the NAT instance, and we'll save this, close, right? Let's try now. What is going to happen? Let's try. Okay, so that's good. So let's see if we can. So we are in the private instance. Let's see if we can first curl, right? If we can curl www.google.com. Okay, there you go. See, I can curl google.com, but I think the ping will not work. The ping is still not working, right? The reason is because, remember, when we created the NAT instance, we did not allow the ICMP in the NAT instance, right? In the security group. So what I'm talking about is here. So if I go down to my NAT instance, and if you see the security group here, in the inbound, you see there is no ICMP. That is why HTTP is working. I'm able to curl, right? SSH obviously works, but I'm not able to do ping. So let's add that. Let's add the rule, which is, where is ping? Here, ICMP before. And this one, I can probably, yeah, I think this is good. So because we want only from our VPC, right? So that's fine. And everything looks good. So let's save this. And now if I come back here, right, if I ping, there you go, it's working. Awesome. So we actually provided, so we did this, we actually completed what we set out to do. We set up the public instance, we set out the NAT instance, we set out the private instance, and we provided it internet connectivity towards, you know, the internet. Now, like I said, the NAT instance was a little tricky. There was a little bit of too much of manual effort, right? We had to set up the instance, we had to set up the route, we had to set up the permissions. You saw how I had to set up the HTTP permissions, the ICMP permissions, and all of that, right? So there is an easier way to get the same thing done, and that is using the NAT gateway, right? So that's using the NAT gateway. So the only change in that case would be, let me just go and erase this part, right? So this one is going to be gone. Instead of creating another instance over here, we'll basically end up, let me use the red one, because these are all not instances. They are not EC2 instance. So this is another, think of it as just like your internet gateway, think of it, this one also as an appliance or something, right? So NAT, it's basically managed by AWS. So that's a good thing about this particular NAT gateway. So I'm going to call this as the NAT gateway. And this one you don't have to manage. AWS manages it, and it gives you higher bandwidth, availability, and you're going to be charged only based on your usage, right? Unlike your EC2, right? So here you're going to be charged only based on your usage, and you can I think get up to like 45 gigabits of throughput or scaling, right? Bandwidth. You can check the documentation, but you can do all of that. And the main thing is, you don't want a security group to manage this guy. You see, I'm not going to put the green circle around this because there is no need of a security group. So it kind of reduces your work a lot, right? So we'll see how we can set this up. So to set this up, first thing is we'll go to our instances, and we'll shut down this NAT instance. We really don't want this guy anymore, right? So we'll terminate this guy here. It's always good to terminate stuff which you really don't want, right? So when I do that, you can see from my instance, I lose my connectivity. There you go. See, I'm not able to connect to the internet, which is in line with our discussion before. Cool. And we also will go to my VPC, and let's see under the under the private, let's refresh this guy. And you see here there's something called as a black hole. Why? Because the default route doesn't exist anymore, right? We were pointing this guy to the NAT instance, but the NAT instance doesn't exist, so it's showing as black hole. We'll fix this. So we'll go down to the NAT gateway. We'll create a NAT gateway, and when we create a NAT gateway here, we'll have to obviously select the subnet, right? And I always get confused as to the subnet names here, so we'll have to probably go and, or I think there are stuff here, so I think I can use this. So yeah, so we have to basically put the NAT gateway obviously in the public subnet, right? Because we want a public IP for a NAT. That's how NAT works, right? You need to have a public IP for your NAT for that, so that it can then translate the private addresses to public, right? So we'll use the public subnet A in this case. There you go. And once you select that, excuse me, so the elastic IP allocation. So for a NAT gateway, the other thing is you want an elastic IP. You want a constant IP. You don't want this IP to change every time your instance boots up, right? So you want a permanent IP. So that's why we're going to allocate one. Right, there you go. I'm allocating it one. I can delete it obviously once I finish the lab. So I'm going to allocate here, and once done, next what do we do? So we are going to create a NAT gateway. Right, let's close this. So I've created the NAT gateway. You can see here it will take few minutes for this guy to come up. Meanwhile, what we'll do is let's go to our routing tables. Where are our routing tables here? And let's go to the private routing table, routes. Let's edit this guy, because this guy is going to black hole, right? So I'll have to edit this out to whom? I'll have to point this now to the NAT gateway here. So there is the NAT gateway. I'm going to save this. So as soon as I do that, you see here this changes from black hole to active. Right? Now for the ping to work, we'll have to wait for a few minutes until the NAT gateway comes up. So I'll have to wait for this guy to change from pending to active. So let me just pause the video and come back when it is done. And there you go. Our NAT gateway seems to be available now, which means let's go back here. Right? Let's do that ping now. There you go. Right? We are able to ping. So we achieved the same thing which we did before, but this time we achieved it using a NAT gateway instead of using a NAT instance, right? So isn't this cool? Like, we are really designing the whole VPC ourselves, right? We are not letting AWS do it for us. We are creating our own instance. We are making sure how the routing tables are going to be there, how it connects to the internet and everything, right? So AWS does give you so much flexibility when it comes to it. Now, next thing is we'll talk about ACLs, right? The network ACLs, which is interesting as well. So just a quick diagram here. How the network, I just want you to picturize this, right? So you have your EC2 instance here. Think of it this way. So your EC2 instance, and you also have the security group surrounding it, right? Protecting your EC2 instance from all directions. But your your security group, right, is per instance, right? So when you create an instance, you assign a security group to it. So it's more like a per instance kind of a protection, right? But so this is what it is. But network ACLs protect you at a subnet level, right? So if you have multiple instances in a subnet, you can create one network ACL and it is going to protect you. So think of it here, right? So you're gonna have right, something like this, a network ACL, right? And this guy is going to kind of like, so this is let's actually put something here. Let's call this as a subnet, right? You're probably going to have multiple EC2 instances here, and the network ACL is the guy who is going to protect you, right, in both the directions, this one as well as this one, right? So you're going to have on the network ACL side, you're going to have the inbound roles and you're going to have the outbound roles. And remember, the network ACL is stateless. So whatever you allow in this direction, you will have to manually allow it on the outside direction as well. Whereas security group is stateful, which means, so you have security group here. So this guy also has a inside and outside, right, rules. But here it is stateful, which means if you allow something in the inside direction, then automatically it will get allowed in the outside direction, right? Because that's how the stateful works. You allow a flow in the inside direction, it's going to allow in the outside. So just a segregation, and now we are going to play around with this network ACL just to check out what it is, right? So quickly, what we'll do is we will go down to the network ACL. Where is it? Here, there you go. So there's a network ACL, and this guy gets created again by default. You know, all the 4 subnets which we have, you can see the subnets here. There you go. So all the 4 subnets present in our demo VPC, right, is attached to this network ACL. We can create our own network ACLs if you want. I'm going to just rename this guy to default. My spellings. ACL. There you go. So it's a default network ACL. Interesting, that did not go. I'm going to say default network ACL probably. Yeah. So it's a default network ACL. And you see in the inbound roles, everything is allowed, right? You have this, just like your traditional ACLs, you have the sequence numbers, right? Everything is allowed. Outbound is also, everything is allowed, right? So that is the current situation, right? But before playing around anything here, let's go to our public instance and let's run our web server, because we'll not be able to test otherwise. So to run our web server, let's come out of this private instance. Right, so let's do that. So let's get rid of here. Let's come out of here. Let's clear the screen a bit. And what are the commands you need to run a web server? We have done this quite a lot. Before that, let's also change this security group of this guy. So what is the security group of public instance? It's allowing only SSH. So let's go and edit this, and let's allow HTTP as well. Otherwise, you know, there's no point in creating Apache if you are not allowing this guy, right? So let's probably get rid of this guy, and let's save this. So it's going to allow HTTP now, and let's go back to our item, and let's say sudo su and yum install httpd, right? There you go. It's going to install the web server, but just installing is not enough. I'll have to provide yes here. Okay, let us install. That's good. And once it is installed, I'll have to go with system CTL, right? I'll have to do enable httpd. Okay, same thing. I'll have to say start as well, right? Because it has to start the service. Now I can do something like echo hello world, right? I don't want the default Apache web page, so I'm gonna pipe this into the where folder, www and HTML, I think, and inside that we'll have index.html. Okay, okay, I think there was a mistake. Echo www. Let's see, let me fix this. Give me a second. All right, probably it was some kind of a syntax error. Anyway, so we have I've put in the hello world in the index.html, which means if I go to this IP address now, there's that instance. Let's pick the IP address, which is this guy, and if I go to the instance, right, it should give me hello world, which is fine, perfect. Now let's play with the network ACL. So what I'm going to do is, in the network ACL, in the inbound direction, I'm going to put a rule. I'm going to put a sequence rule which is before this all traffic rule, right? Otherwise, there's no point in putting a rule. So I'm going to put 80, and I'm going to say HTTP. Where is HTTP? Over here, right? I'm going to put the HTTP from anywhere, but I'm going to deny it and save this. Now, because of this network ACL, let's see. Let's pick the same IP address. Let's open it in a new tab. There you go. I'm not able to connect to the instance anymore. The reason? The network ACL, which I was talking about here, right, is preventing the HTTP traffic in the inbound direction. Right? So that's important, right? So let's probably go back. Now, the other thing which I want to show you here is if I edit the inbound rule and change this from 80 to say 200, it will not have any impact, because the first rule which is going to be hit is this guy, right, the all traffic one. Let's save this. Let's pick this guy again. Let's go here, and there you go. See, now I'm able to connect. So it's very important to notice the sequence number and put the correct sequence number based on what you need. Now similarly, let me also show you the other stuff. So if I go to my security group, let's go to the security group, and which is the security group, or let me go to the instance actually. Let's go to the public instance. Let's go to this security group, and in the outbound direction, what I'm going to do is I'm going to delete this guy, right? I'm going to delete the complete outbound rules, right? So I'm deleting all the outbound rules from the security group, right? So let's see what is going to happen in this case. Let's pick the same guy. Let's open it in a new tab. Give it a second. Yeah, so it does take a few seconds for the security group to come into effect, but you see we can still connect to the instance, though we have completely removed, you know, the outbound rules in the security group, because it goes back to my earlier conversation that the security groups are stateful. Because we have a rule which allows the HTTP traffic inside, it doesn't matter if you have a rule outside, right? Because once the traffic comes in, it is going to allow the traffic to go out, right? So that's something which I wanted to show. So NACL or the network ACLs are stateless, whereas your security groups are stateful. So let's just go back and add our guy back in, right? This is going to be from anywhere, and probably with that it's fine. So yeah, we've added back our security groups. Okay, so that's mainly with respect to security groups and NACL. So the last conversation which I want to have here is VPC peering, right? So VPC peering is very interesting. So again, let's go back to the diagram. So what if, so this is our VPC which we already have. What if we have one more VPC, right? And we want to talk to that VPC. So think of it this way, right? So so this is one VPC. Let's say we have another VPC here, right? We have one more VPC here, and we want to talk, right, between this VPC and the other VPC, right? So in that case, we can basically do that, and we are going to do that using what we call as peering, right? So these both VPCs will be able to talk to each other. So that's a completely different VPC, right? It is a VPC in itself. It has its own instances, and it is going to have its own NAT gateway, whatever. But if you want these two VPCs to talk to each other, right, then it is possible, and we are going to actually achieve that. Okay, cool. So how though? So to do this lab, it's going to be pretty quick again. All right, so if you want to quickly do this lab, what we are going to do is let me show you. So let's go to the VPC again. Let's look at the VPCs. Let me remove the filter, and you see we already have two VPCs. One VPC is what we created, and this is the default VPC, right? I said every time you connect to AWS, you basically get a VPC, a default VPC. So this is the default VPC. So instead of creating a brand new VPC, what we'll do is we'll make sure that the demo VPC is able to talk to this default VPC using peering, right? So before we can actually connect and make them work, I want to show you that currently they are not able to talk to each other. And for testing that, we'll have to create an instance in this default VPC, right? So let's go here. Let's say launch instance. Let's create a new instance, T2 micro, and here in the selection of VPC, I'm going to select the default one, right? I don't care which availability zone. Let it pick whatever it wants, and I'm going to say add storage. Probably add a tag. So this tag is going to be for, right? I'm going to say this is the default instance, because this guy is getting created where? In the default VPC. Sweet. Configure security groups. I'm gonna retain, this is going to be obviously default instance, right? So this is the default, let's say default security group, right? It's going to have just SSH for now. Review, launch. Yeah, that's fine. I can use the EC2 itself, launch. All right. So there you go. We have the default instance which got created in the default VPC. All the rest of the instances were in the demo VPC. Now while this guy comes back, what I'll do is let me, this is actually, where am I? This is in the public, right? So let me split the screen here, right? Let's go to the downloads folder. and here, okay, so SSH EC2 dash user at what is the IP address? So we'll have to check the IP address from here. Let's go here. Okay, I'm able to connect to it. Awesome. So let me clear the screen on the left side a bit. All right, so on the left side I have my VPC, the instance in the demo VPC. On the right hand side I have it, let me just go out of root actually. Okay, so on the right hand side I have it in the default VPC, right? So remember, I already have a web server running on my this guy, right? So let me curl localhost. Remember, we just created a web server, right? So I'm going to do a curl, and there you go, it is giving me hello world, right? But from here, if I try to connect to that guy, how do I connect? Pretty simple, right? What is our IP address here? 10.0.0.71. So I'll do 10.0.0.71, right? And let's do port 80, curl port 80. You see, right now I'm not able to connect, right? It is just stuck there. But at the end of this lab, we'll be actually able to connect, right? Because right now these two instances are in two different VPCs, and our whole objective is to make them talk to each other. Sweet. So what we'll do is, let's go to, for that we'll have to do peering, right? So let's go to VPC peering. Where is peering? So let's go to the VPC console. Let's go to VPC peering here, and let's create a peering. So here I can give any name, let's say demo peer probably, and here the requester. So the requester VPC, I can put it as my demo VPC, right? And you can connect to, so this is what I wanted to show you. So you can actually talk between two different VPC in different regions, different AZs, and different account also. So if you have one more account, or if you want to talk to an instance which is set up by your friend in a different account, you can do that as well. In my case, it is going to be the same account and same region as well. Both are in AP South 1, right? So I'm going to retain that, and I'm going to select my default VPC here because that's what I want to talk to. All right, so let's go and say create. Okay. Now it is saying pending acceptance, so I'll have to do right click and accept request. Accept. Close. There you go. It is active now, right? Is that enough? Let's see. Oh, there's one more thing, right? We have to edit the routing table also. So let's go to the routing table, and in the public routing table, because that's where my instance is, right, in my demo VPC. So I'll have to edit the routing table to basically make sure that the other VPC is reachable, right? So I'll have to edit the routes. So let's go to the routes, because without that, remember, routing table is the one which actually connects everything together, right? So what is the before this, let's see, what is the subnet for our default VPC? We have to figure that out. Remember, I showed you this when we started out, but let's figure out here. So this is the subnet for our default VPC, right? Let's copy this guy, and let's go to the routing table. Sorry, let's go to the routing table of this guy. Let's go to the public routing table. Let's edit the routes. Right? Let's add a route. So this is the route of our default VPC, and here what I'm going to do is, which one do you think I'll have to select? The peering connection, right? There you go. This is a peering connection. I've put the route, but it's a two-way thing, right? So I have put a route on my, it's like static route, right? I put a static route on my demo VPC. I'll have to do the same thing on my other VPC as well. So let me just remove this. Let's go to this guy, and let's say edit route. I already know the route, right? It is 10./16. Remember, that's my demo VPC. So I'm going to put that over here, and here also I'm going to select the peering connection, select this guy, save routes. Awesome, right? So we have done that. Now let's see the magic. Let's run the same command here. There you go. We are able to talk to the web server, which is actually running in VPC demo, right? So this hello world was basically running here. Earlier we were not able to connect to it, but now we can, right? So what we did is we actually used this peering connection, and we were able to talk between two different VPCs, right? So that's a lot of VPC stuff today. There's actually, this is probably again, probably just 25% of it. There's actually a lot more you can do with VPC. Like you can also, now if you have a data center, right? If you have a data center of your own, you can set a site-to-site VPN with the VPC as well. So that's something which I would ask you guys to explore. Maybe if I have some time in future, I'll make a video on that. In addition to that, we have something called VPC endpoints, where your VPC, instead of going through the internet to talk to some other AWS services, we can put a small exit point here and we can talk to the web services directly, right? Other AWS services like DynamoDB and S3, CloudWatch and all of that, right? But anyway, so this was a lot of thing to take in, right? I would definitely ask you guys, and if you're following the series, just go ahead and replicate everything I did today, and you'll get a very good understanding about VPC, right? So thanks for watching, and have a good day. Bye.